All right, let's talk about one of the most intense, high-stakes races happening in technology right now. We're talking about the global push to build the next-generation battery. And believe me, the company that wins this won't just be powering our cars. They could literally control the future of energy itself.
So let's just jump right into the big question. Imagine a battery that gives you a 600-mile range and can charge up in just 9 minutes. I mean, that's faster than you can grab a cup of coffee. The technology exists. But for investors, for engineers, for all of us, the real question is, can it ever actually escape the lab? Is this a real scalable business or just a super cool science experiment?
To really get why this race is so frantic, you have to understand the prize. And it's so much bigger than just a better battery. This is about breaking through the walls that are holding back our entire electric future.
I mean, just look at this. Solid state isn't just a tiny improvement. It's a complete game changer. We're talking about a battery that's better than today's lithium-ion on literally every single metric that matters. Nearly double the energy density, charging in minutes, not hours. It's safer because it can't catch fire, and it could last for thousands of charge cycles. It's the whole shebang.
And of course, where you have a tech revolution, you gotta follow the money. The financial side of this is just staggering. We're looking at a market that's projected to explode from about $380 million to over $6 billion in just a few years. That's a growth rate of almost 50% year over year. Just insane.
So who are the big players here? Who's actually in this race trying to grab that prize? Well, it's definitely not a one-horse race. We've got a whole field of contenders, and each one is betting on a very different way to win.
Okay, so it really boils down to two competing philosophies, two different ways to build the engine of this new battery. On one side, you have the sulfide approach. On paper, it looks great, but it's been having some serious durability issues. Then you have the oxide ceramic camp. Now, this one is way harder to manufacture at scale, but if a company like QuantumScape can crack that code, well, the payoff could be absolutely enormous.
And this is where it gets really interesting for investors, because you can see the world's biggest car companies placing their bets. It's like a high-tech horse race. VW has gone all in on QuantumScape's risky but potentially revolutionary ceramic tech. Ford and BMW, they're playing it a bit safer, backing the sulfide team with solid power. And then you have Toyota, kind of doing their own thing, betting on their legendary in-house R&D. It's this incredible web of alliances, with everyone trying to make sure they're not left in the dust.
Okay, so we've met the racers, but here's the thing. It doesn't matter which technology they've picked, they are all running on the same incredibly difficult racetrack. And this is where things get really tough. Now, this is the part that everyone needs to understand. Making one perfect battery cell in a lab, that's the easy part. The real monster is building millions of them flawlessly. You've got these little villains called dendrites, tiny metal spikes that grow inside and can kill the battery. You've got interfacial resistance, which basically chokes the flow of energy. And then, the biggest beast of all, just trying to manufacture them. Right now, yields are sometimes barely over 50%. That's a coin flip.
And if the technical hurdles weren't enough, we have to talk about the elephant in the room, cost. Just look at this gap. Right now, making a solid-state battery costs 4, maybe even 8 times more than a standard lithium-ion one. That is a massive price gap that absolutely has to close before you and I will ever see this in an affordable car.
So, how do you solve some of these problems? Well, one of the coolest ideas comes from Samsung. To stop those nasty dendrites, they created this silver carbon anode. It's brilliant. It basically guides the lithium to behave itself. It's a really elegant solution to one problem that, well, creates a completely new and very shiny problem of its own.
Just look at these numbers. It's kind of nuts. A normal EV today uses a tiny amount of silver, maybe 30 grams. Samsung's prototype, it needs a full kilogram of silver. A kilogram. That's a nearly 30 times increase. You can see how this quickly becomes a major supply chain headache.
And what happens when you try to scale that up? Well, the numbers just get astronomical. If only 20% of the EV market, just a fifth, were to use this tech, it would create 16,000 metric tons of new demand for silver every single year. For a metal that's already in short supply, yeah, that's a huge problem. But here's the amazing part. Despite all of those massive hurdles, the cost, the manufacturing, the silver, the leaders in this race are not slowing down. In fact, they're starting to round the final turn. We have actual timelines for when we might see these on the road. And this isn't some far-off futuristic dream. The timeline is surprisingly aggressive.
pilot production lines are already ramping up. By 2027 or 2028, companies like Toyota are saying they'll have cars with these batteries for sale. And by the end of the decade, the Holy Grail, they could finally be as cheap to make as lithium-ion.
Now let's be realistic. Solid state isn't going to just flip a switch and take over the whole market. By 2030, the forecast is about 15% of new EVs. But don't let that number fool you. That's not small. That's the beachhead. That is the critical tipping point that signals the beginning of a whole new era.
And that really brings us to the heart of it, to what's truly at stake here. This quote says it all. The winner isn't just going to sell a lot of batteries to car companies. They're going to, and I quote, effectively control the most critical industrial resource of the 21st century. Think about that. So that leaves us with the big question as we head into this final lap. Are we watching a sprint to a single winner-take-all technology? One battery to rule them all? Or is the future something more diverse? A whole fleet of different batteries, specialized for different jobs. The race is on, and the next few years are going to tell us everything.